So here we go. What I did is I put together like a deck of sheets, which is an integration of words, explanation, and R code, and then results produced by this R code and some graphs. And we're going to go through these sheets, and we're from time to time going to switch to R to run some instructions together. Okay, so here we go. So first of all, by means of a bit of introduction, the material for today is available on a repository that I put on GitHub, that I created on GitHub. So you see the link here, which I also posted on Toledo yesterday. So here you can find the data sets we're going to work with, these lecture sheets that you see over here. You'll be able to download them from this repo, right? The sheets are available in HTML as well as PDF, so it's up to you what you prefer. But of course, for the HTML to display the sheets correctly, you'll need some helper files, which are also available on this GitHub repo, right? Of course, there will also be some R scripts where we find the actual instructions of the models that we're going to build. I created this deck for a training that I developed with Jonas Krevekeur, who used to be my PhD student, but who recently graduated and is now a postdoctoral researcher in the COVID team of the biostatistics section at KU Leuven and University of Hasselt. So what do you need in order to go along with me? So we're going to work with a bit of R. So what you need is a fairly recent version of R in order to reproduce or to redo the instructions that we're going to work with. And I'm using the IDE for R that is called RStudio. So an IDE is an interactive development environment, right? That's it. So it's a way how you can interact with R, let's say, right? And we're also going to rely on a few R packages. So we'll also need to install these R packages along the way. And in order to facilitate all of this in an online teaching environment, what I think is the most easy way for you to join the coding part of today's session is that you create an account for the RStudio Cloud. And on the RStudio Cloud, I put a project dedicated to our classes this week. And if you just copy this project, you've got everything you need, and you'll be able there to run our code, our instructions in the cloud, right? So I'm going to show you how that works. I also saw that a few students already created their own copy of the project. So that's, I guess, the most easy way to follow along today. Of course, you can also go for a local installation of R in RStudio on your own computer, but then you should be able to install the additional packages on your own machine. Right. So what are we going to try to do? We're going to work a little bit with some data handling, some visualizations, exploration of data. And then, of course, we're going to jump to fitting loss models, in particular, the kind of distributions that we've been discussing for frequency data on the one hand and for severity data on the other hand. So this deck, as it is right now, covers both frequency and severity modeling. I'm still thinking of a few extensions. So if I find the time, I may add some additional sheets for Thursday, for the Thursday session. But if I don't find the time, we'll just use the sheets as they are right now. Yeah, but I've got some other ideas that I want to show you. So we'll see how that works, right? So the idea is to work a little bit on your own. Huh? So there will be some exercises here and there. So learn by doing, get you started, in particular when your experience with R is limited. Okay, so here we go. Why R and RStudio? So this is a question that we can spend a lot of time on. Huh? So why do you show us some demonstrations with R? Why not Python, for example, or SAS or Stata or whatever? So I have a few arguments over here. But this is, of course, a debate that one can go on, that can go on for like forever. So you can read these kind of, you can read the bullets listed here. You can list the bullet, you can read the bullets over here. And I think what is important, it's just the language or the environment that at least I know best. So that is my natural way to go if I need to fit some models in a software package and if I want to work with data. If you're very interested in the discussion R versus Python or when to use one or the other, I kindly refer you to the hyperlinks here at the bottom, which I think are very interesting discussions and which I invite you to take a look at if you have some time and if this kind of discussion is interesting, is of interest to you. Now this picture, what I'm going to do is I'm going to rely on packages that are part of the so-called tidyverse. So I think throughout the assignments that we put together, you've already been working with some courses on DataCamp dedicated to this tidyverse. And I want to show you this picture because what we refer to as the tidyverse, it's kind of a universe of a couple of R packages. A couple of what we call opinionated R packages. So it's a particular philosophy, it's a particular way of living, if you want to put it like this. And these packages, they apply a sort of consistent syntax and a consistent way of working across these various tasks that you see summarized here in the picture. So it's something that with the team or with the lab in Leuven, we're using a lot throughout our projects. But today we're going to use or a selection of the packages like dplyr to prepare our data. We're going to do a bit of ggplot visuals. And we're going to use the pipe operator here and there to calculate a few things, right? So if you want to read, if you want to know more about this, here you can see what this tidyverse is. It's an opinionated collection of R packages designed for data science with an underlying design philosophy, grammar, and data structures, right? And you can follow the links here. You can follow the link over here to learn more about what is inside this universe. So the name tidyverse is coming from tidy, which is a term often used here to clean up your data, to make sure your data have a tidy structure with observations in the rows, with variables in the columns, things like that. And then tidy and universe put together, that's the tidyverse, right? So one of the first things we're going to do if we go to the R code is to install the packages from the tidyverse and make sure that we've got these packages available throughout the session. All right. So here is in a nutshell what I put together. So this also allows you to navigate throughout the HTML sheet. So if you follow the links in pink, you will be directed to the specific chapter in this deck of sheets, right? So we're going to start with loading a few data sets that we want to work with, a data set for frequency, a data set for severity. And then for today, I want to focus on fitting some frequency models in R and make sure that I understand a little bit. If I want to go to the Poisson or the negative binomial, stuff like that, how can I fit that model to my data set? And how can I verify whether this model, this fitted model, makes sense for my data? And then on Thursday, we're going to dedicate the session to severity modeling. So we're going to work with a few parametric distributions. And we're going to do this splicing idea, which we discussed in class. We're actually going to calibrate this spliced model on the secure array dataset, which we also encountered in the classes, right? So that's a bit the idea. So if I look at the datasets that I'm going to use throughout the session, we've got, first of all, a dataset called MTPL. So that's a dataset so MTPL is for motor third-party liability. Yeah. So in Dutch, that would be the burgerlijke aansprakelijkheid. We've got 163,000 approximately policyholders in the dataset. And if I look at the target variables, so the outcome variables that I want to focus on, I've got the frequency of claiming, which is called here N claims. And I've got a corresponding average severity, that is here the amount paid on average per claim reported by a policyholder. So for the demonstration on the frequency models, I'm going to focus on modeling this variable N claims, right? And I do have a few predictor variables. So the first bullet here refers to the exposure to risk, which we encountered in the previous session. So we know that that is important to take into account, because if you report one claim on a full year, that is a different setting compared to when you report one claim on only 6 months of insurance, right? So you want to include this exposure to risk when you are building frequency models. This is something we did in the previous session. And now beyond this exposure to risk, we also got like really predictor variables, features, covariates if you want. They are listed here, but that's not the goal of our course, to explain the number of claims reported as a function of these covariates. That's what we're going to do in the course that I'm teaching in the second semester on data science for insurance. So there we're actually going to use these predictor variables. But today we're only going to focus on the number of claims and on the exposure to risk, right? So if you look at, yeah, and here you see a few references where we also analyzed this data set. So one of the first things we need to do is load this data set, which is given to you in the course material as a TXT file. We need to make sure that we can load this data set into R, that we can import the data and start working with it, right? Now, there are different ways to do that, but what we tend to use is a structure, or is a kind of reference. What we tend to use is the use of so-called relative paths, right? So that means that if you just stick to the structure of the material as I posted that on GitHub, or as I put it on the RStudio Cloud, that using the structure, you can then use a so-called relative path name. And I'm going to explain that on the cloud, how that works, right? And when using these relative paths, I can say, well, what I need to do is, yeah, let me just explain that on the cloud. Otherwise, it's going to be a little bit difficult, right? So let me just pause this explanation and come back to you when we switch to the computer code, right? So why do we do it like that? Because we want to avoid referring to a specific working directory on your computer. So for example, this type of path name, this is something that would work on my machine, but of course it would not be working on your machine. So that's something we want to avoid. And that's why we use this relative path structure from the previous sheet, right? So I'll come back to that when we go to the cloud, and you can read a bit more about the philosophy and the kind of working over here. So what we're going to do is we're going to load the data, and we're going to save the data set or the object that we create. We're going to save that under the name mtpl org. Yeah. So if I ask the structure of this object in R, so str is for structure, then I see it's going to be a tibble with 163,000 something observations in the rows and 18 variables, right? And here you see the different names of the variables. So for today, this is way more than what I will be using. Today, I will be focusing on the number of claims and on the exposure. And I basically will ignore all the other variables. Now, one of the awkward things here is that all these variable names are in capital letters, capitals. So I want to change that. And another inconvenient thing is that the exposure is abbreviated with exp, which I find inconvenient. So I want to change that to expo, right? So here is how we're going to do that. So what we're going to do is we're going to take the original object, mtpl org. We're going to apply, and we do that with this pipe operator that you encountered when you did this data camp course the tidyverse. So this pipe operator allows you to put things sequentially together. So you really have to see it from left to right. Take the MTPL ORIG dataset and then do the following instruction. We're going to use the rename all instruction or function from the dplyr package, which allows us to rename all the variables in our dataset. And in this case, we're going to take a variable name and we're going to change it to lowercase letters. And to code that in R, you could do .name and then the pipe operator to lower, where the to lower is a built-in function in R that tells you, okay, take this string and change it to lowercase letters. And then as a final step, I'm going to apply the rename function from dplyr, and I'm going to say, instead of working with expo, instead of working with exp, I want to work now with the name expo, right? And then we create eventually an object called MTPL, and that will be really be the object we're going to work with, which stores the data in the way we want it to be. Okay, so I'm going to show that on the cloud. Let me just let me just tell you that here I then listed a few things that you could try out. So if you want to do some basic investigations into the variables and into the data set, you could, for example, start with calculating the empirical claim frequency per unit of exposure, then do the same per gender. How would you do that? You could do a few plots, visualizing, for example, the distribution of the number of claims with a bar plot, use the geom bar as a layer in the ggplot, and so on and so forth. So what you will see is that after these exercises, I always have the solution printed on the next sheet. So you will be able to explore and to have a look at this solution, right? So we'll come back to that, but let me just jump to introducing the next data set, and then we can go to the R environment and try a few things ourselves. So the next data set we're going to work with is the so-called Secura RE data set, where we have claims from 1980 to 2001 from several European insurance companies. All of these claims exceed 1.2 million euro. The data were corrected for inflation. They're also available from the REINS library package, which we will encounter on Thursday. But for now, they're just available to you as a TXT file. So you're going to read the data, load the data by using a read.table instruction. And you're going to store the data in an object called Secura, right? And if we plot the density of the losses, and you can try to do that, then we see that the losses are positive. They have a distribution that is skewed to the right. They tend to have a heavy right tail. And in this case, they're all also, the losses are also subject to left truncation, right? So this is what we're gonna explore, right? I also listed an additional exercise where you need to try to visualize the distribution with a density plot, do the same for the logarithm of the loss, and plot the losses versus the years. And then you should get something like this. Over here, I have a bullet or a dot for each loss observed, and I plot the losses against their year of occurrence. Yeah, so that's a lot, but let's now switch to R and do a few things together, okay? So what I'm gonna do is I'm gonna use my project on the cloud. So that's here, that looks like this on my screen. Make it a little bit larger. And I'm gonna open in the workspace Loss Models Computer Labs 2020. I'm going to open my project that's called December 15 and 17. So that's for today and for Thursday. And I'm going to start from there, right? So what you would see here is the following environment, which should be quite similar. If you start or if you work with your own with your own environment on your machine. So you've got the scripts over here, which you may still need to open. You've got the console over here. And here you've got a bit of structure, like which files do we have, which plots did we create, and so on. And here you also see in the global environment, which data sets did we create, which variables did we create so far, etc. Yeah. So the idea is that you're going to start with a script, which is called day one, and then the participants version. That means that the exercises are not completed yet. If you look at the complete script, that means that the exercises have been solved for you. Yeah, so it's up to you which one you want to use. Also make sure that the installation instructions, so these contain a few packages that you need to load. So make sure that you run the script before you actually get started, right? And in order to run a script in R, what you're going to do is you're going to open the .r file. You can do that with file, open file, and then look for the script. And then you can select the instructions. And you can go for the run here, top right, or what else can you do? You can put your cursor in front and you can do Control Enter. That's another option to run the instructions one by one, right? So here on the cloud, the packages have been pre-installed for you. So if you run the installation instructions, you should get the message that everything is set up correctly and that we're ready to go, right? If you do this on your local machine, then I guess that the software will start installing these packages in case you haven't installed them earlier on. Right, and what we're going to do is, after installing the packages, we're going to go to the script day one participants. And we're going to start from here. So let me just get that started, and then we'll see how that goes with everybody. So first of all, I'm going to load the tidyverse. So that's something I can do with the instruction library tidyverse. So I put my cursor in front, I can do Control Enter, and I can load this packages from the tidyverse. And then the next step that I want to do is I want to load the PC dataset. And now you have to check a little bit because I'm going to explain it first, how the structure on the cloud is. So what we're going to do is we're going to use the package RStudio API. So I made it. So we're going to use the package RStudio API. And from this package, we're going to use the instruction get active document context. And then I do $path. So what this thing is going to do, this first instruction, it's going to give me the name of the directory where this particular file, so this particular R script is stored. Yeah. So on the cloud, if I type this dir, you'll see that it's saved under cloud project scripts, right? Or for your local machine, that is of course going to be different. Yeah. But the whole idea is that you here with a bit of an automatic function, part of this RStudio API thing, we're going to get the directory where this current R script is stored, either on this cloud or either on your local machine. And what we're then going to do is we're going to change the working directory. So we're going to set the working directory to the path that we stored in the variable or in the object dir. And what we're now going to do is, what our working directory now is, and you can check that if you type get working directory. What we're now going to do is we're going to work relative to this working directory that we just specified. And on the cloud here, that means if I look at my structure, I've got my cloud, I've got my project, I've got my scripts. So what I want to do is I want to leave the scripts folder. I want to go back to the root folder, so to say, to the project folder. And there I want to go to the subfolder data and get the txt file from there, right? So in R, what I'm going to do is I'm going to use these two dots to do so. So that means from my working directory, I'm going to go to the parent folder. And in this parent folder, I'm going to go to data and I'm going to pick up this txt file, right? And then I do a read.table instruction because I want to load a txt file and I want to work with this txt file. So if you do this instruction, you should see that you create an object, mtpl orig, if that went well. And if you type structure or str of this object, you should get like a print here in the console that says, okay, it's a data frame, it's 163,000 observations of 18 variables, and so on and so forth, right? And then the final step that I'm doing here is I change the data frame into a so-called tibble, which is the basic data format in the tidyverse. So if I then type again the structure of mtpl orig, I see that it has now become a tibble with 163,000 observations and 18 variables and so on. Yeah. So I can check that with typing the structure. I can also see the first 6 lines. If I do the head instruction, so with the head instruction, I get a quick view on my data set. So I see the first 6 records being printed. I see the variables. I see the values that my first 6 observations take. And so what I think I will do is I'll just show you a little bit more what I'm doing with this mtpl orig. So if you look at the pipe instructions that you see over here, so slice is an instruction from the dplyr environment, and it will allow us to give a slice of the data set. So in this case, I ask to show me row number 1 up to row number 3. So that would give me, if I just do these 2 instructions, that should give me the first 3 observations, the first 3 records. So that's what this slice is doing. And then in order to be able to print my tables on my sheets, I noticed that I have quite a lot of variables. So what if I want to leave out long and let, for example, at the very end? Then I can just say do select, but do it with a minus. So that means if I rerun this instruction, that I'm just going to ignore these 2 last columns, let and long. And with the intention of printing my data in a nice way, I can just select the variables that I want to include in my print. Okay. So in the next instruction, we're going to change the variable names to lowercase, and we're also going to rename the exposure variable to something that has no affiliation, let's say, with the exponential function, and which avoids any confusion over there. So if you do the following 2 instructions, and then you check again the structure of mtpl, you see that now everything is in lowercase and exp has been changed to expo, right? So I can also recycle like the instructions that I had over here, for example. I could also recycle them over here. But instead of mtpl orig, I should now work with mtpl. I ask the slice with the first 3 records and I get the print like this. So we're good to go. We can check the dimensions of our object. So we know how many observations, we know how many variables, right? So here the idea in the your turn is that you try to code a little bit yourself with the exercises that I listed on the sheets. So let me just leave that for now a little bit, and let me also import the Secure Array dataset so that we're good to go with building the frequency models after the break. So with the Secure Array, you will see that in the data folder, there is another txt file. It's called Secure Array. The header is true means that I'm going to recycle the variable names as they are used in this txt file, right? So if I load the data set, I get Secura, and if I then type structure of Secura, you should see that you now have a data frame with 371 observations and only 2 variables. There is the year of the loss and there is the actual amount of the loss that's being reported, right? And if I would then picture the density of these losses, or if I would start building some graphs, then we can go back to our sheets and see how I did that, right? So let me just show 1 or 2 examples, one for the frequency side and one for the losses. So if I want to show you, in the sheets how to do this, I guess I can just switch over here. So for example, if we want to do this kind of graph for the Secura loss, Secura re-losses, I'm just going to copy the instruction just to be a bit faster. So I'll just copy this ggplot instruction from my sheets. I can go to my cloud and I can paste it over here, right? And I can think a little bit. So what I'm going to do is I'm going to create a ggplot. I'm going to use as the data set, the data stored in the Secura object. As the aesthetics in my plot, I'm going to use year and loss. So year will be on the x-axis, loss will be on the y-axis. I like the black and white theme in ggplot because otherwise it's going to be like a gray background. And I'm going to add some points. So I added geom point layer to my canvas. As the color, I like the K11 color, but I guess I didn't define it yet, so I should fix that. For the size, I'm going to use 2, and for the transparency of the dots, I'm going to use this 0.5, right? And then as the last step, I'm going to add this instruction, gg title, so which is going to add a title to my plots.